Cancer is definitely a rising threat worldwide, and the rates continue to rise.
Unfortunately, both my dad and my mom died of cancer. My experience pushed me to try to find some answers.
Cancer is really a disease of the genome. Everybody's genome is personal and everybody's genome is different. So we need to understand that relationship between the personal genome and the cancer that is attacking it. The only way to do that is to sequence.
HPV, or human papillomavirus, is a sexually transmitted virus, and it infects cervical cancer cells. We want to see why this is so important. What does it change upon integration? What does it change for the genes in the cervical cancer cells as well?
We know that cancers evolve. We try to destroy them by using pharmacological treatments, chemotherapy, but they become resistant. By using long-read data, I have found a novel molecular mechanism by which tumors become resistant to chemotherapy treatments. Probably it's one of the biggest challenges for the next, I don't know how many years.
We're doing research on uterine leiomyoma and colorectal cancer. We hope to improve the patient care of both of these very common tumor types. It affects about 70% of women at some point of their lives, so it's a huge burden to society.
Genomics England was set up as a partnership with the NHS a number of years ago in order to establish whether sequencing, in particular whole genome sequencing, was of benefit in clinical practice. So conventional sequencing that we're doing currently for standard of care with the NHS is associated with short read sequencing. But the really novel thing and the really cool thing about nanopore sequencing is that it provides us with really long fragments of sequenced DNA. And that allows us to do things we can't do with conventional short read technologies.
Without nanopore sequencing, our work wouldn't be possible.
And Nanopore really allows us to see these really large chromosomal changes that affect big portions of DNA, how that can affect the cancer as a whole.
It's been said that all cancers are different. You can't really differentiate between two cancers without sequencing.
Future generations hopefully will see cancer with a lot more clarity. With all the information that nanopore sequencing and other sequencing technologies is giving us, we can eventually put this all together to understand cancer as a whole a lot better.